Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome back in lecture 12. Student, basically, as you know that in lecture number from 6 and onward to lecture number 9, I think so, we covered this question number 5 of our major assignment and question number 6 as well. Okay, so these two questions are basically related with the analysis of composite section. Okay, so if all those students which they join me yet, okay, I first of all advise them that to please watch those 6, 7, 8, 9 lectures, because I am here to cover a design of in this lecture 12, sorry, I am going to cover the design of a composite section. Okay, so that's why if you don't watch those lecture number 6, 7, 8, 9, so you don't understand this question. Okay, so therefore please watch those 3, 4 lectures. In question number 1, what we wanted, basically this is also an assignment question. The layout of the beam and girders of a typical warehouse floor is shown in figure. Okay, the live load is 400 psf. The slab thickness is 5 inch, concrete strength FC prime is 4000 psi, and steel is A36. Determine the beam required. Okay, now we have to choose these beams. Okay, the configuration of the system is such that you see that this is basically, let me choose my pen. These are girders. Okay, because the girders are those beams, you can say, which is directly supported over the columns and they directly transfer the load to the columns. So these are the columns. Okay, and there is the column, here is the column, and here is also the column. Okay, now these are, you can say, our secondary beams because they transfer the load to the girder and then girder transfer that load to the columns. So the beams are spaced at a distance of 12 feet center to center. You see here, this distance in between the beams is 12 feet. Clear? Center to center distance is 12 feet. You must remember this. Okay, 12 feet, and this one is also 12 feet. Now the length of the beam is 36 feet. Clear? Now if I show you a picture, here you see that in this picture basically what we have, you see that we have girders. These structures are girders. Okay, this one is a girder, this one is also a girder. Okay, and they are supported directly over the column, but these are our secondary beams, you can say. Okay, they are transferring the load to the girder and then girder transfer them to the column. Okay, here you also see. Now, if we move forward and if we move forward to solve this question, okay, what we have slab thickness, because this is a composite section. We have live load given, FC prime strength of concrete is given, steel section strength is given. Okay, so this is the question, and here you see the data. Clear? Live load is given, thickness of slab is given, strength of concrete is given, the steel section is given. What we need, we have to find out the tributary area for each beam. Okay, so remember, as this is the interior beam, this one is the interior beam. Okay, so it will take the load half from that panel and half from that panel. So that's why its effective area width will be 12 feet. Clear? So this is the tributary area for this interior beam. Remember, interior beam. If we are going to design this exterior beam, so this will be the tributary area for that beam. Okay, remember, half of the tributary area of this interior beam. Clear? So there must be no confusion to you people while you are designing the exterior beam. Remember, there is a half loading to that beam. Clear? Now Let's move forward. We have to make some assumption while we are designing basically a composite section. What are the assumptions? The assumptions are that we assume that the beams are simply supported. Remember, although the beams are basically connected to the girder, okay, here you see that the beams are connected to bolt connections basically there, but we assume that these beams are simply supported. Remember, because therefore we are assuming this kind of assumption. Basically we use this kind of assumption that the rigidity, or you can say of this connection is not too much, okay, that it will completely you can say completely provide affects behavior to this beam, okay. It cannot control totally the movement of the beam. So that's why basically we assuming that that the beam girder connection is a simply supported. Clear? If you are going to assume them as a fixed support, then you have to basically provide a very rigid connection to this beam girder connection, okay. So in that case you can't use that assumption there, okay. But this is a conservative approach if you assume that there is a simply supported connection, okay. So you must remember this assumption, okay. The next assumption is that without shore construction. Remember, without shore construction. What is shore construction? What is unshore construction? I explained this, all these terms in lecture number 6, 7, 8, 9. Okay. So you need to watch those videos. Assuming that the beam having full lateral support during construction. It is also an assumption, and I always explain these terms basically in those lectures. What does it mean? Okay. So basically find the beam required, okay. So this assumption is that this means that when your beam is basically during construction, we remember here we have another beam, okay. Here we have another beam, okay. Now we provide such kind of arrangement that these beams are laterally basically, because there is corrugated steel sheet over these beams, and those sheets provide lateral supports to these beams. So that's why we assume that the lateral support during construction is basically complete lateral support, okay. So that's what means that LB equals to 0. Okay, this assumption basically make LB equals to 0. And please watch those lecture number 6, 7, because I don't want to waste my time on this kind of assumption. I explained these terms in very detail in those lectures. Okay, we need to find out the self weight as usual we did, okay, in previous lectures. We need to remember, you have to multiply them with 150, that is the density of concrete, okay. Weight per linear foot, okay. So this is per square foot. We have to multiply them with a 12 feet effective span, because we have to find out a one strip load, okay, one strip load. So as 62.5 is per square foot load, remember it is per square foot, and we have to integrate this square foot load for a distance of 12 feet. So that's why we multiply this square foot loading with a 12 feet to convert them in a one strip load, okay. So basically we are designing the beam for a 1 linear feet, remember. So this is pound per feet, not PSF, okay. Live load per foot we need, because 400 PSF we have to multiply them with 12 feet to convert them in a strip. So that's why it is LB per feet. Clear? The loads to be supported before covering up concrete are the slab weight and the beam weight only, okay. And the loads to be supported after covering up concrete, slab weight, beam and live load. So I explained them in my major assignment in this question, okay, when I covering this question in lecture number 9 and 8, I think so. I explained these terms, okay, that what it basically mean, okay. So next we have to find out our factor loading. So this is our factor loading. Okay, total factor loading 8,580 pounds per feet, and this is the total movement. Remember, this is the total movement. The composite section should be able to support this movement because we are adding live load. Okay, now try a nominal depth of 21 inch. Remember, this is how we can start our design. Okay, this is how we can start our design. Basically, we have to assume that we have to use 21 inch nominal depth beam. Okay, a nominal depth. Okay, the estimated beam weight per feet. For this, we have a formula. Okay, we have a formula, and this is the unit weight of a beam, and 3.4 mu divided by pi b fy d by 2 plus ts minus a over 2. Remember, this is the formula to determine the weight of the beam which you are going to use, because you have to encounter the weight of the beam. Okay, still we don't consider in this loading, we don't consider the weight of the beam. So we have to add up the weight of the beam because we are in design process. So that's why to find out the weight of the beam, you have to use this formula. Remember, and A should be assumed. Remember, this should be assumed, and in later stages we will check it. Okay, so the weight of the beam is 116.68 pound per feet. Now we add this load with a dead load and find our modified factor load. Okay, let's say using section W21 122 section. Okay, let's say this is our first trial, that we assuming that we are using W21 cross 122 section. Check the unshored steel shape for loads applied before the concrete covers. Remember, this is the analysis. Now we start our analysis. If you watch lecture number 8, 7 and 9, the analysis which I had done in this question number 6, it will help you here. Okay, if you code this example, you will be obviously automatically you code this section, because the rest of the part of this question is same just like question number 6 as I covered in lecture number 8 and 9, I think so. So therefore I don't want to waste my time, okay, on these calculations. Okay, you just need to find out your dead load, because you have to add the beam weight, and this is our dead load coming from the slab. You have to factor them. Now this is the load which is prior the concrete cover before 28 days. This load is taken by the beam. Okay, this load is taken by the beam because the concrete is still fresh. They are not able to take its load. Okay, and the composites action is not yet be achieved before the 28 days. Okay, now they use W21, so you just need to visit the manual. Okay, find out the section, what section we are going to use. W21 cross 122 section. Okay, W21 cross 122 section. Here we have 24, here we have 21, and here we have this section. Okay, you see here its ZX is 307, and its strength here from this is the strength of that section, because we are make sure you will be in right table. Okay, F36. So here we have 829 is the design strength of that section. Clear? So if you have ZX from that table, you can directly choose this one. Remember, or if you have a ZX value, you can use your normal equation, that is y Fy into ZX. You can gain this one, multiply this with kf inch divided by 12, you got this one. Okay, so it is more than 167. So we are okay. We are okay, but before 28 days, when the concrete doesn't cover, means the concrete yet in fresh stage. Once the concrete, after the concrete covers, so when the concrete covers, the beam, the composite section action we will achieve and now the beam and concrete combined taking the total load. But remember here the total load is changed because we have to consider now the live load, because before curing up concrete we do not consider the live load right here, no live load, remember. But once the concrete cured, you have to consider your live load. So that's why your factor load is increasing, your movement is increasing. Now at this stage you have to support 167 foot movement, but here once the concrete cured, you have to support this movement. Now this is now your factor movement. You have to design the section for this movement. So that why, although the beam is efficient in taking that load before the curing, but now as we achieved the concrete is hardened and the composite action is we achieved, so we need to find out the composite section strength. Okay, we need now the composite section strength, and I explained them thoroughly in this question, that how you can calculate, and as well as in question number 5 I also explained that how you can calculate, because you need effective width, remember, you need your nominal depth, you need TS, and TS is given, this depth is given, the section is given, you have to just find out effective width and then use the rest of the formula. So what they did, basically they find out the effective width, L by 4 or center to center distance. The minimum one is this one, this control. So your effective depth is this one. You have to find out your steel strength ASFY, and that is simple. You have to find out your concrete strength, so that is ACFC prime, and remember AC is 108 times 5. Remember AC is the area of concrete, okay, which is just over the concrete section, the beam section, sorry. This is our beam section, okay, and now you see this is our concrete section right now, okay, this one. The effective width of this concrete section is 108, okay, this is the effective width, and the thickness of this concrete is 5 inch. So the area AC is now 108 times 5. So that's why they multiply 108. The strength of the concrete is this much kips, and you have to select the lower one. So this one is control. So your C value will be this one. Now you need to find out your A. So A is nothing, this smaller value C divided by 0.85 FC prime BC. You have, this is BE, sorry, this is BE, this is effective weight. So you just need to plug the values. You got 3.52 inches. Your A value, you need to find out your movement arm or lever arm, and I already explained this formula, okay. And here you see this is your lever arm and this is your section, okay. Here you see your section, your ASFY, your C value, your A over 2, and your nominal depth 28.68 is your nominal depth. Remember, this is the actual depth. Go to table 1.1, okay, and find out this depth, because the section we just assume that is W 21 cross 122, I think so. Let me check it. 122, okay. So 122 section, the nominal depth of that section is 21.68. Remember, this is this depth. Remember, this is depth is this depth, okay. This is 21.68 actually, okay. And you need to find out your pi b mn, that is pi b into c y, and you know the c value is this one and y is determined here. So once you got your value 13.65 and this is less than, so the section is not okay, okay. Now you again use for another section that is a heavier section than that one, okay, because the strength is now lower than the required movement. So that's why we revise the section. We go for a higher depth section, that is 24 from 21, remember, and 117, okay. The weight is reduced but the section depth is increases. Now you again need to find out, because we have 117, so that's why
our section weight is now reduced. Okay, so that by 1.040 feet you got your movement, that is 168, almost same 167. So what you need, you go to table, find out the section, this one W24117, and you got your ZX value. Okay, the procedure is simple. Okay, there is, here we have W24117 section, where it is W2494, okay, little bit 146, this one. Remember, now we are using this section, so its ZX value is now this one, and its strength will be this one. Okay, but remember, this is just only the strength of your beam, of your steel beam. Okay, we are not considering the composite action. Okay, now we have to next determine the composite strength of the section. Okay, so this strength is basically just only the strength of the beam. Remember, this is just only the strength of the beam section, not the strength of the composite section. Okay, here after the covering, once we coming to the second stage, now we are considering the composite section. Okay, and the strength of this composite section now will be more than the first one. Okay, because once your concrete covered, okay, it start its behavior and taking loading. Okay, so this section, the movement capacity of this section will be more than this one. Okay, will be more than this one. So that's why we now the composite section, basically when the concrete covers, the live load coming into picture, and now we have to add that live load. Here you see, we don't consider live load, but after covering we have to consider live loading. So that's why the movement will always remain same. Okay, but now we see the section strength. Okay, A is Fy, C value. Okay, you need to find out the smaller one, that is the smaller one. Okay, remember, when this A is Fy, as I explained in this question number 6, basically that when your A is Fy control, sorry, your C control, this is the strength of concrete. Once your strength of concrete C is greater than A is Fy, okay, A is Fy, then what we have, what does it mean? This means that the neutral axis lies within the concrete. Remember this point, and I already explained this in this question. I think so, question in lecture number 8, lecture number 9. So please watch that lecture. Okay, if this is not, if this is less than this one, so the analysis procedure will be different. Remember, we can't use the rest of the calculation. We have to change our calculation. Okay, so that's why as C is greater than A is Fy, so therefore we are using this calculation. We find out lever arm, okay, and then we recalculate the strength, and the strength is this one. Now you see 434, which is more than 412. So that's why this section is okay. So finally we select W24117 section is okay. Now very important note, this may not be the final section. We have to check it from deflection criteria. If it pass the deflection, then it will be okay. And I think if you watch this lecture, you will obviously understand this note. Okay, because sometimes the section which you select, as I explained them in question number lecture number 11, that the best way, the best approach is that you just choose the section on the basis of your deflection criteria. Because if we check this section for deflection, I think so, I am not sure, but this section will be failed in deflection. I am not sure because I don't check this section. If you check it, so I think so it will be failed. If it is failed, so you have to revise your section. So the best way of choosing a section, you just choose the section on the basis of deflection criteria and then go for your flexure strength. If the section passes the deflection criteria, it automatically passes the flexure criteria as well. Almost all the time it passes the flexure criteria. But if you choose the section on the basis of the flexure criteria, as we did here, and then you are going to check them for a deflection, then it may or may not pass sometime, but almost it fails. Okay, so that's why the best approach is that I did inshallah lecture number 13 and 14 as well on this topic. Okay, so the best approach is that you select the section on the basis of deflection criteria. How to check the deflection criteria I explained in this question. Okay, so please watch that lecture number 8 and 9. Okay, in that in lecture number 7, 8, 9. Okay, I explained these two questions. So if you understand these two questions, because these are analysis questions, so you will obviously understand the design of the composite section. This will ends up. If you have any question, any suggestion, please share your questions, watch the video and enjoy. Thank you.